In this lecture, I'll give you an overview of artificial intelligence and machine learning. Standard automation and programming tools like Ansible, Terraform, and Python are very good at the deployment of straightforward and predefined rule-based configuration and monitoring tasks. For example, pushing an enterprise's QoS policies to all its network devices. This simplifies and speeds up these operations and reduces human error. So what you can do is you can load your QoS policies for your routers and your switches into a central location, and then you can push it out to all of your devices from there. That is a lot more efficient than doing it one by one on each different device. You're a lot less likely to have a typo because you're pushing it from the central location, and that's also going to make it a lot faster as well than doing it one by one. Automation tools, however, are not so good at more complex dynamic tasks. For example, learning the normal network traffic patterns over an entire network, recognizing anomalies in that traffic, and automatically taking corrective action on it. Trying to do that with traditional tools, even traditional automation tools, using static policies and configurations would be practically impossible to do. Another example of traditional systems having limitations is with your security systems. Traditional intrusion prevention systems use signatures to inspect packets, looking for traffic patterns which match known attacks, which have already been pre-programmed into the IPS. That does not secure against new unknown threats or anomalies that do not match those predefined signatures. Now, I know that traditional IPS systems typically do support some anomaly detection, but they're not capable of analyzing huge data sets collected over time across the entire network, or of predicting future patterns. So with machine learning and AI, it's capable of analyzing traffic patterns which have been collected over a long period of time across your entire network, across all the different devices. So that can be a huge amount of data. With an IPS, it can look at the data, the network traffic going through it, but it's not going to be capable of analyzing everything across the whole network and not over extended periods of time. Also, IPSs are not capable of predicting future patterns, but AI and ML is able to do that. So artificial intelligence can help with more complex dynamic network tasks that your traditional methods and automation tools are not able to do. Cisco define AI as the simulation of human-like intelligence by computer systems. That intelligence is capable of pattern recognition, learning, reasoning, discovering meaning, problem solving, and self-correction. So things that we would normally associate with intelligence in humans. But general intelligence, where a machine has the overall intelligence of a human, is a hypothetical goal that is not possible right now. Current applications are narrow AI, which means that they've been designed to perform a specific task, such as generating text. AI is a broad term with many different usages and techniques. We'll cover a lot of them in this section. Some examples of where artificial intelligence is used is web search engines, such as Google, recommendation systems like the YouTube algorithm and Netflix, where it recommends what you should watch next, speech interaction like Alexa, autonomous self-driving vehicles, gameplay like the IBM Deep Blue chess machine, and creative tools, for example, ChatGPT. And looking at these, for example, web search engines, you wouldn't really think of that as being AI. This is because when an application becomes commonplace enough, it is no longer thought of as AI. But Google uses a lot of the same methods as ChatGPT does, and ChatGPT has actually been at the forefront of a lot of the recent buzz about AI. Okay, next let's cover machine learning. Machine learning is a subset of AI. So it's not a different thing. It actually comes under the umbrella of artificial intelligence. Cisco define it as mathematical and statistical methods that enable machines to mimic intelligent human behavior by learning from data without being explicitly programmed. It can analyze huge data sets, so huge amounts of data. When it does that, it can identify patterns, relationships, and anomalies, differences in that data. And it can automatically improve its performance as it gains experience by analyzing more and more data. Like a human, to understand the data more fully, it must be trained. And there's different training approaches. Now, the training approaches are not actually part of the CCNA curriculum, but I'm going to cover them here because it's going to give you a much better understanding of exactly what machine learning is and how it works and what it's doing. So the different training approaches are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Starting off with supervised learning. Supervised machine learning learns patterns and relationships between input and output data. For example, it's given an image of a dog as input, and it then classifies that with a text label as being a dog as the output. So you could feed lots of images into this machine learning system, images of dogs and of cats and of different animals, and it's going to learn what a dog looks like and what a cat looks like. The computer is presented with labeled data showing example inputs and outputs. So you give it a big data set with lots of images of dogs, and you say, these are output dogs. And it's also got lots of images of cats, and you say, these are output cats. So you've got labeling on that training data set. Then the machine learning system learns what the different characteristics of dogs are and that they should be classified as dogs. And later on, you can give it new images of dogs after it's gone through the training process, and it will automatically know that this should be classified as a dog. So once you've gone through the training phase, the computer can map new inputs, new images automatically. I'm just giving images as an example here, but you could be giving it really any kind of input and output data, such as also text or video or audio. A more complex example of supervised learning, because that one with classifying images of dogs as dogs is obviously a pretty simple example, where a more complex example would be a bank loading a customer data set which contains the balances and credit history of their customers and which customers defaulted on which loans. So with that, with their balances and credit history, say the customer got a loan for a particular amount of money, did they default on that or not? Then, when new customer information is input, the computer can predict if they're likely to default on a potential loan as the output. So that would be a very useful use of machine learning for that bank. The next kind of method we have got is unsupervised learning. Unlike supervised learning, unsupervised machine learning is given unlabeled data, and it's allowed to discover patterns and insights without any explicit guidance or instruction. So again, supervised learning means that a human has labeled that data so that the machine knows for this input what the particular output should be. But with unsupervised learning, there is no labeling. The machine is just given the data and it's left to itself to go and recognize the different patterns and relationships and any differences, anomalies within that data set. So it infers its own rules to structure the information based on those similarities, differences, and patterns. It can cluster the data based on similarities. It can create association rules based on frequent if-then patterns. So if it sees a particular thing happening in the data, and then after that, something else typically happens after it, it can use that to create if-then patterns. And it can also discard the least relevant information as well. So that's kind of the inverse of creating the clusters. Where it sees the relationships between the data, it can create clusters of them. It can also recognize data that seems to be quite irrelevant in that data set as well. A data analyst is still required to validate the outputs. For example, if we give it that same data set where we were giving it lots of different images of animals, then we would expect the unsupervised learning, machine learning, to make a cluster of the images which were dogs and a cluster of the images which were cats. But because it's unlabeled, it doesn't realize, oh, these are cats and these are dogs. So you as a human would then have to go and say what those clusters actually are. Unsupervised learning can be used for network anomaly detection, where it discovers patterns that are unusual in a data set of network traffic statistics. So that's just an example where we can use it as network engineers. We also have semi-supervised learning, which is a blend of supervised and unsupervised. A small amount of labeled data, in addition to unlabeled data, may produce an improvement in learning accuracy. And the last one I'm going to cover is reinforcement learning. With that, the data is accumulated from trial and error. So data is not provided as the learning method. A reinforcement agent decides what to do to perform a given task that you've given it, and it learns from its experience. After each action that it takes, an algorithm receives feedback that helps it determine whether the choice that it made was correct, neutral, or incorrect. An example of reinforcement learning is a chess playing machine. It can play itself to automatically learn the best move for each situation. So what you would do is you would just program it with the rules of chess, and then you would leave it to play itself hundreds of thousands of times so it could learn all the different situations that it could get into and what the best move was for each of those different situations. Okay, so to summarize that, we have got supervised learning, which uses labeled data. We've got unsupervised learning, which does not label the data. And then we have got reinforcement learning, which we do not use a data set at all. We just use trial and error in the machine learning. And to explain the difference and give you an example of the difference between artificial intelligence and machine learning, let's say that machine learning can analyze huge sets of network-related data, learn normal network patterns to do baselining, and detect anomalies. Artificial intelligence functions can then report on anomalies and automatically take action on them, predict future patterns and issues such as upcoming congestion, and recommend optimum settings. So the machine learning learns about the data and it learns about the patterns in that data. Artificial intelligence takes action on what the machine learning learned. So it can do things like it can report on those anomalies that machine learning found, and it can automatically take action on them as well. It can also, based on the previous and the current patterns that were learned by machine learning, it can predict what is probably going to happen next, what the future network patterns are going to be. It can also predict issues such as congestion that is coming up, and it can also recommend optimum settings. So it can look at the configuration of our devices and it can make suggestions about how we can improve that. It could also recommend optimum settings for what it predicts is going to happen in the future as well, because maybe we need to change our configurations. All right, the last thing that I want to cover here is predictive and generative AI. And those terms, it's pretty obvious and self-explanatory what they mean, but I'll explain it anyway. So predictive AI utilizes algorithms and modeling to analyze past and current data to forecast future events and behaviors. It's predicting the future. Machine learning is used to understand the data and predict what is likely to occur later. An example use of this is to determine maintenance cycles and predict early faults in machinery based on past events and environmental factors such as heat and vibration. So with the data that we load in, we can show there what the normal maintenance cycles are, how often we normally have to service our equipment, but it's more intelligent than that. It can also take environmental factors into account as well, such as what the recent weather has been like. Has it been more hot lately? It can also look at the vibration, again, environmental statistics of our actual machinery. If it sees a part which is vibrating an unusually high amount, it can report on that as well. So by having this information, we can predict what our future maintenance schedules should be to make them more accurate, to prevent failures, also predict when a failure is going to occur, and swap out the hardware part before that actually happens. Where we can use it in network operations, we can use it for proactive maintenance and also performance optimization. AI can analyze past and current traffic patterns and anomalies, performance statistics, help tickets, maintenance history, and environmental factors. For example, we could load all of those in order to forecast problems such as future security issues, future congestion in the network, links becoming too busy, and hardware failures. By having that information, that enables us to optimize the network now and also prevent future issues from occurring. Okay, last one is generative AI. So with predictive AI, that is used to predict future things that are going to probably happen. With generative AI, it uses patterns and relationships learned from past data to create new outputs such as text, images, audio, and video. Supervised learning is typically used for the training of generative AI. The machine is given a set of labeled data and learns to generate similar content. So, for example, from that data set that we were using before, we could use generative AI to produce new images of dogs. ChatGPT is a well-known example of generative AI. It can generate text. Example usages of generative AI are enhanced chat, search, language translation from one language to another, and creation of marketing content, music, and homework essays. So with the big buzz around AI, most of the buzz has been around generative AI and things like creating new images, creating new videos, which can be used for viral content and for marketing. Also, another big one where universities and schools were worried that students were going to be using ChatGPT to do their homework and they wouldn't even be able to detect this, so students would be able to pass without actually doing any work. Generative AI can be used to generate network traffic pattern simulations when we're using it with our network operations. That's useful to identify potential issues under different conditions and help plan for future upgrades without affecting the real network. It can also create optimized network settings and configurations, so it can make suggestions on what would be better configurations based on our network now if we're going to be doing a planned upgrade. Traditionally, a large part of that would be figuring out what all the different configurations are going to have to be on the devices. With generative AI, we can use AI tools to help generate those configurations. We would still want to check them, but it can give us less work to do. Also, if we have a current issue, a current problem in the network, this can help with troubleshooting. It can help detect the problem, and once the problem has been detected, we can also use it to generate configurations to fix the problem as well. Be careful when creating configurations or asking networking questions with general tools such as ChatGPT. They're not optimized with network data and are susceptible to hallucinations. What hallucination is in generative AI is when it gives you an incorrect answer. ChatGPT, it's one of the known issues about that is it is susceptible with doing that. So do not rely on it. Do not trust it when you ask it a question about something you want to know about networking, or when you're generating a configuration. That's why you're doing this course. That's why you're learning this. So you're going to know what the correct answer is itself. You can use AI tools to help you, to save you time generating configurations, but you definitely want to check that they are correct. And I've actually been talking about ChatGPT quite a bit here, so let me just show you it. You probably know already, but in case you don't, let's have a look. And hopefully I still can just paste this in. Okay, so I've gone to chatgpt.com and then I give it a text-based prompt. So ChatGPT is text-based. It takes text prompts as an input, and then it gives you text as an output. So I've asked it to create an OSPF configuration for me, and I've said what my interfaces are and what the IP addresses are on those interfaces. I hit enter, and it just takes a few seconds, hopefully, and it should give me a configuration. Okay, there we go. So there is my sample configuration for OSPF, and I've got an explanation down there as well. So this is a lot quicker than writing it myself. It is quite useful, but you definitely want to check it. I'll actually be talking about RAG later in this section, which is a way that you can optimize your data sets to make sure that they are actually correct and going to be more relevant and up to date. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.